And now we have the motion question, which has distances and times and rates. Oh my. I don't know why I suddenly decided to talk like the Count. So we have a boat that takes 3 hours to go 24 miles upstream against the current. Technically, that's redundant. That is always what upstream means, but mathematicians like to be precise. It can go downstream with the current a distance of 48 miles in the same amount of time. So I'm going to highlight that because that is like mathematician. Here's the thing you're going to forget. Determine the speed of the boat in still water and the speed of the current. Okay. So I need to figure out what I'm going to call those two things they just told me to determine because those are the variables I should be using. So the speed of the boat in still water, the boat speed. I am partial to actually calling it B. You could also call it X if you want. I am actually going to go with B because I don't plan to graph these. The speed of the boat, B. Speed of the current. I'm sure we're shocked I'm going to go with C. All right. So these are speeds, and if I look at my units, I've got miles and hours. So the units on these are going to be MPHs. All right, but speeds, distance, time, we need to use one of our speed is distance over time, or whichever way it ends up working. I usually start with distance equals rate times time. Do chart. Dun, 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 dun. And then the first part they tell us is upstream. And then we have downstream. But the better words here would actually be against and with. So it doesn't matter if it's a current, if it's an airstream, whichever. One of the ways has the current detracting, the other has the current helping. Because remember, the only variables we get to play with here are B, the speed of the boat, C, the speed of the current. So when I go upstream, let's check out what we got. I got 3 hours. And I got 24 miles. And I need something for the rate. Let's fill in the other things we know though. Downstream with the current, the distance is 48 miles for the same amount of time. Cool. It was the same amount of time and they gave us the number for that. Yay. So both of those are 3 hours. And then I just have to figure out my rates. Now from this, knowing the distance, knowing the time, I could figure out the effective rate upstream and downstream. Before we do that though, because that is going to be one of our steps, I want to talk about what's going to go in this rate column using B and C. So the speed of the boat, and then when I go against the current, that's going to slow me down. So we're going to have B minus C. So the boat cruises along at like 50 miles per hour, which obviously is not right here because we'd be done way less than 3 hours. But boat's going at like 50 miles per hour, and then the current minus is 10 miles per hour off of it, say. Apparently we're in a hurricane. It'd be minusing though in math land. Then downstream, they're going to add. Now it looks like these numbers will be a tiny bit more realistic than the numbers I pulled out of thin air. But that's the key on these upstream, downstream, with the wind, against the wind. B minus C, B plus C. Make sure, like the one where you go against, you either go less distance or you take more time, but it's slower. With, you're going to go through it faster. So in this case, for the same time, we go more distance. In fact, twice as much. All right, and now I'm going to follow my formula, distance equals rate times time. So I have 24 equals, now the b minus c and b plus c need to be in parentheses. Technically, everything in the columns we could put parentheses around them, but usually it's just a variable or a number. Once you get more than one, use the parentheses. And then over here, times 3. And so just right now looking at it, if I divide by 3, I end up with 8 equals b minus c. And isn't that much nicer to look at? So these equations, very, very often, they're going to give you the time. And if you divide it over right away, instead of distributing it, you end up with much more nicer looking equations. All right, so same thing on the second one. That is 48 equals, now it's b plus c times 3. Divide both whole sides by 3. That is going to be 16 is b plus c. And now let me take this over here. Hey, look at that. What do you know? The c's already set to cancel. So 2b's is going to be 24. So 1b is 12. 12 miles per hour. So the boat speed is 12 miles per hour. That's why I like to use not x and y. So I got to figure out the current speed now. Well, I prefer to go back to the 16 equals b plus c. So that would be 12 plus c. Well, I didn't need the parentheses, but again, safe math. Minus the 12, so the current is 4 miles per hour. So on my upstream trip, you got 12 minus 4, only 8 miles per hour. 8 times 3 is 24 miles. Then when I go downstream, now I'm going to add 12 plus 4. I'm effectively going 16 miles per hour. And in 3 hours, I am indeed going to go 48 miles. So you can check these once you've got a sense for how the setup works. And I have seen people common sense their way to these answers even more frequently. Because people will like look at it and figure out the effective speed. And so it's like the numbers we got here, the 8 and the 16 are actually the effective speeds. So against the current, I only go 8 miles per hour. With the current, I only go 16. The halfway point is 12. And then the 12 is 4 units away from each of those. So the 12 is the boat speed. The plus 4, the minus 4 is the current. All right. That only works though because we got b minus c and b plus c by itself. Different problems are going to have different logics to the answer, but there is still a way to do it. All right. So there's that one done again.